Okay. Good afternoon, students. So far in last class, we have to discuss and revise the data pre-processing task. And the data pre-processing task mainly you have to perform. First one is the data cleaning, second one is the data integration, third one is the data reduction, and the fourth one is the data transformation and data discretization. So these are the four types of tasks you have to perform on data pre-processing. So already in last class we have to completed the data cleaning. And what are the data cleaning? That is the missing values, noisy data, and the data cleaning as a process. You can how to handle with that missing values and noisy data by using the binning. These are all concepts you have to complete in last class. And also you can discuss with the data integration. The data integration, entity identification problem, redundancy and correlation analysis we can do with that. Covariance, covariance and correlation you have to find out uh, by using the data integration. These are the concepts you have to complete in last class. Now in today's class we have to discuss with that data reduction. In the data reduction mainly we have to discuss with that wavelet transforms, program principles component analysis, attribute subset selection. These are the concepts mainly we have to concentrate, and the histograms, clustering, sampling, data cube, and aggregation. So these are the concepts you have to discuss in data reduction. In the data reduction, first one you have to discuss method. Data reduction mainly we have to discuss with that data reduction techniques can be applied to obtain the reduced representation of the data set that is much smaller to in value. It closely maintains the integrity of the original data. Generally, data reduction strategies are for three types of strategies mainly you have to follow. In the data reduction, mainly these the three strategies. One is the dimensionality reduction, second one is the numerosity reduction, and the third one is the data compression. First one is the dimensionality reduction. Dimensionality reduction is simply you can say that it is a process of reducing number of random variables attributes under the consideration. Generally, in a dimensional reduction methods are wavelet transform methods and a program component analysis method, which transform the project in original data into the small spaces. Attribute subset selection is a method of dimensionality reduction in which is the irrelevant and weakly relevant redundant attributes of the dimensions are detected and removed. So these are the three types of dimensional reduction methods. One is wavelet transform, second one is the principal component analysis, third one is the attribute subselection. So second one is the numerosity reduction. In the numerosity reduction, mainly it is a technique to have to replace the original data value by alternative smaller forms of the data representation. Generally, these techniques may be parametric and non-parametric. You have to represent the numerosity reduction. Parametric method, the model is used to estimate the data so that typically only the data is parameters need to be stored. Instead of actual data, outliers may be stored. Regression and nonlinear models generally we have to call. What are the non-parametric methods? Generally, in numerosity reduction, you have to divide into two types. That is the parametric and non-parametric methods. Parametric methods are regression nonlinear model. What are the non-parametric model? It is storing the reduced the representation of the data, including histograms, clustering, sampling. All you have to come under this numerosity reduction and non-parametric method. Parametric method అంటే generally regressions and nonlinear models only you have to use. But non-parametric method, those are histograms, clustering, sampling, and cube aggregation. You have to come under these non-parametric methods. So generally, the data reduction you have to divide into three types. First one is the dimensionality reduction. Second one is the numerosity reduction. Third one is the data compression. First one is the dimensionality reduction. Again, dimensionality reduction we have to divide into three types: wavelet transforms, principal component analysis, and attribute subset selection. And the second one is the numerosity reduction. We have to divide into two types. That is the parametric methods and non-parametric methods. Parametric methods are the regression nonlinear models. Non-parametric methods are histograms, clustering, and sampling, and cube aggregations methods. And the last one is the third type of reduction method is data compression. Data compression is the transformation is applied to so as to be obtained a reduced or compressed the representation of original data. If the original data can be reconstructed form of the compressed data without any information loss, the data reduction is called lossless. Or instead of reconstructing only the approximation of the original data, the data with the reduction is called lossy method. In the lossless method and lossless method we have to use in the data compression. This is regarding to that data reduction methods. Uh, and wavelet transforms and the principles of component analysis, attribute subset selection. These three are the generally we have to call it as greedy historic methods we have to use. For example, attribute subset selection we have to consider. In the attribute subset selection, we have to show this diagram which shows heuristic methods of the attribute subset selection, forward selection and backward elimination. Decision and trade induction mainly we have to use. Here we have the uh, basic heuristic methods. These are the steps you have to follow. Stepwise forward selection, stepwise backward elimination, combining a combination of the forward selection and backward elimination, decision tree induction. These are the these are the four steps you have to follow in the greedy methods of this attribute subset selection. First one is the stepwise forward selection. The procedure starts with the empty sets of the data set, the empty sets of the attribute as the reducer set. The best of the original attributes is determined and added to the reducer set. At each subsequent iteration or step, the best of the remaining original attributes are added to the set. And second one is the stepwise elimination, backward elimination. The procedure starts with the full of set of attributes, and at each step, it removes the worst attribute remaining in the set. The next one, combination of the forward selection and backward elimination. The stepwise for the forward selection and backward elimination method can be combined so that at each step, the procedure selects the best attribute and removes the worst among the remaining attributes. Decision tree induction. Decision tree algorithms ID3 C4.5 and CART are the originally intended the classification. These the decision tree algorithms construct the flowchart like structures where each internal node devotes test on the attributes. Each branch corresponds to the outcome of the test, and each internal leaf node denotes the class prediction. At each node, the algorithm chooses the best attribute to the uh, partition the data into the individual classes. When decision tree induction is used for the attribute subset selection, a tree is constructed from the given data. All attributes that do not appear in the tree are assumed to be irrelevant. The set of attributes are obtained in the tree from a reduced subset attributes. Such attribute construction is the help of improving the accuracy and understanding the structure of the high dimensional attributes, high dimensional attributes data. So that is regarding to the regression linear model for the parametric data reduction method.
పొద్దున్నే